Hey there, math friends. Welcome back. We're working on lesson 7.3 today, so make sure you write that at the top of your page in your math notebook. And what is today's lesson about? Well, it's solving linear systems of equations using linear combination, or I like to call it elimination. Now remember, a system of linear equations, or just, a linear system, is two or more linear equations that share the same variables. The goal is to find values for those variables that make the equations true at the same time. Now, a real-world example is right here. The cost of buying 8 notebooks and 9 binders is $60, and the cost of buying 6 notebooks and 5 binders is $38. What's the cost of each notebook? What's the cost of each binder? That we don't know, and so we can use variables to represent those. We're going to let x represent the cost of a notebook and y represent the cost of each binder. Now here's what our system looks like. 8x plus 9y equals 60, right? 8 times the cost of the notebooks plus 9 times the cost of the binders equals $60. And the second equation is very similar to that. Remember, x represents the cost of a notebook and y represents the cost of a binder. The solution to the system is an ordered pair, an xy pair, that satisfies both equations at the same time. Now, in this particular situation, the cost of a notebook has to be $3 and the cost of the binder has to be $4. Why, you ask? Well, let's replace those variables with those numbers and find out. In that first equation, if it's $3 and $4, 8 times 3 is 24, and 9 times 4 is 36. 24 plus 36, that equals 60. How about the other equation? 6 notebooks at $3 each, and 5 binders at $4 each. Well, 6 times 3 is 18. 5 times 4 is 20. 18 plus 20, yeah, that equals 38. So that is true for both equations. Now, that's not just guessing, there's math involved here. Now, in the last lesson, we learned how to solve systems using substitution. But it's not always easy to isolate one of those variables. We need another method. So in this lesson, we're going to solve systems using a linear combination, or elimination. Now, these scales that you see here demonstrate how elimination makes sense. I've got 2 limes and a strawberry that are the same weight as 2 oranges. And in the second scale, I have 2 cherries and a banana that weigh the same as a pear. Now, if I combine the fruits on one side, and then I combine the fruits on the other side, by adding those 2 sides together, they still should be equal to each other on each side of the scale, if they started out as being equal. So that's how linear combination works. We are combining linear equations. And it's also called elimination because we're doing that to eliminate one of the variables. So let's look at the steps in solving a linear system by linear combination. Now, you have to make sure that both equations are in standard form. ax plus by equals c. If they're not, you have to make it so. And here are the steps. You're going to want to write these steps down before we move even further. So pause the video and write these steps down. Great, good job. Now we're going to solve our first linear system using linear combination so we can eliminate one of the variables. So step 1, choose the variable to eliminate from both equations. And I am going to choose to eliminate the y variable. And there's a reason, because I can already see that I have positive 3y and negative 3y. When I combine those, they will be eliminated. So let me rewrite my equations. 4x plus 3y equals 16, and 2x minus 3y equals 8. Please write these down. Now, because positive 3y and negative 3y are opposites of each other, when we add these two, when we combine these equations, those cancel each other out, and now I am left with just 6x over here, and 16 plus 8 is 24 over here. How fantastic is that? Now all I have to do is divide by 6, and I can find out that x is equal to 4. Boom, just like that. And now that I know that, I've combined those, so that was step 3. Step 4 is to use substitution to find the value of the other variable. So I'm going to replace x with 4. So I'm going to use the first equation, 4 times 4 plus 3y equals 16. Okay, so now 4 times 4 is 16 plus 3y equals 16. Now remember, our goal is to find out what the value of y is, so we're going to isolate that variable. First thing I'm going to do is subtract 16, the constant, from both sides. And I get 3y equals 16 minus 16, which is 0. My last step is to divide by the coefficient of y, which is 3. When I do, the 3's cancel out, and y equals 0 divided by 3, which is 0. And now we have our solution to the system. X is 4 and y is 0. Now you want to make sure that your answers are right by substituting 4 and 0 into each of those other equations. So you got 4 times 4 plus 3 times 0. That has to equal 16. And then the other one is 2 times 4 minus 3 times 0. That has to equal 8. And make sure that they are. I can guarantee you that the math checks out on this, so I'm not going to waste video time on that. But you should always check to make sure your answers are correct. Otherwise, what's the point in trying to solve them? Now this is a little bit tougher of an example. We're going to solve this linear system. 3x plus 5y equals 6, and negative 4x plus 2y equals 5. Well, okay. So first of all, we're going to choose the variable to eliminate from both equations. I'm going to choose to eliminate the y. So the first thing I need to do is rewrite the equations. So let me do that real quick. All right, there it is. 3x plus 5y equals 6, and negative 4x plus 2y equals 5. Now, like I said, I am choosing to eliminate the y. Now, in order to do that, I've got to do some fancy math. I'm going to manipulate these equations. So I'm going to multiply the first equation by 2, and I'm going to multiply the second equation by negative 5. And you'll find out why I did that in just a moment. Now, so when I do that, so 2 times 3x is 6x. I'm going to go over here. 6x. And 2 times 5y is positive 10y. And 2 times 6 is 12. Okay? And I also have to multiply negative 5 times these. So negative 5 times negative 4, that's positive 20x. Negative 5 times 2y, that's negative 10y. And negative 5 times positive 5 is 25. All right, now hopefully you can see, because now when I go to combine these, I can easily eliminate my y variables because I have a positive 10y and a negative 10y. I have manipulated the equations to get rid of the y value. So these cancel out. So now I add 6 plus 20, 6x plus 20x is 26x, and I add 12 and 25, and I get 37. Oh, wait a minute. No, I don't. The reason is because negative 5 times 5 was negative 25. Oh, silly. All right, so now I've got 12 plus negative 25. That's negative 13. What was I thinking? All right, we all make mistakes once in a while. Now, I'm going to divide by the coefficient of x, which is 26. So those cancel each other out, and that equals negative 13 divided by 26. Calculator time. Boop, beep, beep, boop, boop. All right, and that equals negative 0.5. Negative 0.5. Okay, so now I know what x is. Now that I know what x is, I can go to step 4 and use substitution. And I'm going to substitute that x back into one of the other equations. So, here we go. 3 times negative 0.5 plus 5y equals 6. Okay, now 3 times negative 0.5 is negative 1.5 plus 5y equals 6. I've got to add 1.5 to both sides because remember, I am trying to get that y term all by itself. Those cancel out over here, and I get 5y equals 6 plus 1.5 is 7.5. All right, and then the last step, divide both sides by 5. Those 5's cancel each other out, and y equals 7.5 divided by 5, and that is 1.5. So y is 1.5. So we have an xy pair. Sorry about that, folks. All right, we have an xy pair of negative 0.5 and 1.5. And that's the answer. And of course, we would substitute those back into our original equations to make sure that they are correct. Okay, well, there you have it. If you need to rewatch this video, please do, in case you missed something. And here are your 4 systems of equations to solve using elimination or linear combination. Hey folks, have a great day. Don't forget to be awesome, and I'll see you next time.